So today we are going to talk about algebraic expression. What is an algebraic expression? To understand that, first we have to understand variable, constant, and then we will move to expression. So constant, as we know, is any number. So like 5, it is a constant because it is a number. 2, 7, -8, all of these are constants. Now variable is like any letter or alphabet which can take different values. Here x, y, all these are variables. When we include variable and constants or only variable, then that becomes an expression. So expression will have at least one variable. Without that, it is not an expression. So now we have to identify variable versus constants. So what is this? 7 is a constant. What is x? Is a variable. What is -50? It's a constant. What is y? It's a variable. In 4z, 4 is a constant, z is a variable. Now, which of the below is an algebraic expression? So as we said, the algebraic expression need to have at least one variable. So in this one, there is no variable, so this is not an algebraic expression. This, there is one variable, so this is an algebraic expression. 8y, one variable, algebraic expression. 10 minus 3, there is no variable, so no algebraic expression. I hope algebraic expression is very clear. The bottom line, algebraic expression needs to have at least one variable. Term, coefficient, and factors. So any value which has got both variable and a constant is called term. So for example, if 5x, so 5x is a term. In this, coefficient is the constant. So 5 is coefficient. Variable is normally variable. Now, what is factor? I take a term, I split it into all possible things or all possible constant or variable by which it will be divisible. So 7xy can be divided by 7, can be divided by x, can be divided by y. So each one of this is a factor. It is same as arithmetic. If I get 12, so this can be divided by 2, so 2 is a factor. This can be divided by 3, 3 is a factor. This can be divided by 2 again. So 2 to 3 is the factor for 12. Now 3x plus 2y minus 7. Write the terms. So first in this one, let's first talk about term. Which all are term? 3x is a term, 2y is a term. Now, what are the factors? In 3x, 3 and x are the factor. In 2y, 2 and y are the factor. Same holds true for this. 6ab, 6a and b are factor. Minus 4b, minus 4 and b would be factors. Right? What would be the term? In this one, term is 3x, 2y. 6ab minus 4b. Algebraic terms in that sense. Now in this one, factors, if I have to find out, 10, p and q are the factors. In this, minus 8, x, y, g are the factors. So term, coefficient and factor. Coefficient is the constant part, variable we all know. Term is the combination of one constant at least one constant and one variable. Factor is all possible things which divides that particular term. Now, type of expression, as the name itself suggests, mono. Mono means one. So if there is a variable whose power, or rather if there is an expression which has got only one term, then that is a monomial. Binomial, bi means, what does bi means? Bi means two. So if there is a expression which has got two terms, then that would be binomial. Tri means three. So if there is an expression which has got three terms, then that is a trinomial. Poly means many. So till three we will call mono, bi, and tri. After that, anything is a polynomial, right? So here the name itself is very clear. So what is 7a? Mono. What is x square plus 5? Bi. What is 2y square minus 3y plus 4? This is tri. And there are four terms here, so this is poly. So you don't need to remember anything, just remember mono, bi, tri, the meaning of each one of that, and poly. Like terms and unlike terms. Now see, in the like terms, the variable would be same. So if we look at these three terms, each one of that has only x, 3x, minus 2x, 10x. So these are like terms. If we look at 5x, 7y, in one the variable is x, in second one the variable is y. So they are not like terms, right? So let's practice like terms. 3a, 5a, minus 2a. These are one set of like terms, and 7b, 4b. These are second set of like terms. In this one, 6x, 2x is one set of like terms. This is a separate, 9y is a separate like term, 5z is a separate. They are not like terms. In this one, 10pq and 3qp. qp and pq is same, p and q. So these two are like terms. The third one is not a like term. Now, addition and subtraction of algebraic expressions. So it's very simple. What we do is we first pick up like terms. So here 3x and 5x are like term. So in like term, we will just add their coefficient. So here the coefficient is 3, here the coefficient is 5. So 3 plus 5, 8x. Similarly, 2y and minus y is like term. We will add their coefficient. So here the coefficient is 2. Here the coefficient is minus 1. 2 minus 1 is 1. So we have written y, right? Now let's come to the next one. Now let's first expand this. So 7a minus 2b. Now outside the bracket there is a minus sign. So if we remove the bracket, it will become minus 4a minus 3b. Again the same formula. 7a and 4a are like terms. 7 minus 4 is 3. So 3a minus 2b and minus 3b. These are like terms. Minus 2 and minus 3 is minus 5. So this will become minus 5b. Clear? So in this one, 2x and 5x are like terms. So it will become 7x, and 3y minus 7y are like terms. 3 minus 7 is minus 4. So it will become minus 4y. In this one, again, let's expand. 4m plus 5n. We will remove this bracket. So there is a negative sign. It will become minus 2m. And since there was minus 3n inside, it will become plus 3n. Now, like terms is 2m and 4m. So 4 minus 2 is equal to 2m. and 5 plus 3 is 8, so 8n. Now let's come to the last one. Like terms 6a, 3a. So this will become 9a, 6 plus 3. Minus 2b plus 5b. Minus 2 plus 5 is plus 3. So plus 3b. Plus 1c minus 4c. 1 minus 4 is minus 3. So minus 3c. So addition and subtraction in algebraic expression is very simple. You just have to club the like terms together and then just do the addition or subtraction of the coefficient. Multiplication. Again, multiplication also is quite easy. In case of multiplication, we add the power. So we do not add the coefficient, but we add the power. So let's look at this one where there are two more monomials. So 2x into 2x, 2x into, sorry, 2x into 3x, right? So in case of coefficient, we will simply multiply them. So 2 into 3 is equal to 6. Now x into x, here the power is 1, here the power is 1. We will add these two powers. So x to the power 1 plus 1 is equal to x square. Clear? Now let's come to the next one, this one. Okay. So here 3x into x plus 2. What we have to do? 3x into x plus 3x into 2, right? We remove the bracket. Now in this first case, the coefficient is 3. Here the coefficient is 1. So 3 into 1, 3. X to the power, here the power is 1. Here the power is 1. So x to the power 1 plus 1, 2. Here 3 into 2 is 6. X to the power, here the power is 1. Here there is no x. So x to the power remains 1. So this becomes 3x to the power 2 plus 6x to the power 1, which is 6x. Hope that's clear. Let's look at one more. So this one. Same x plus 2 into x plus 3. Remove the bracket. So x into x plus 2 into x plus this and this 3 into x plus 2 into 3. So first one x into x, x to the power 1, 1. We added the power x to the power 2 plus 2 into x. X to the power 1, there is only one x. So x to the power 1. So there is only one x. So this becomes 2x plus 3 into x to the power 1. There is only one x. So it becomes 3x plus the last one is nothing. 2 into 3, 6. Now like terms 2x and 3x are like terms because the variable is same in both cases with same power. So what will happen? We will write is x square plus we will add their coefficients. So 2 plus 3 is 5, 5x plus 6. So any kind of expression we just have to remember, in case of addition we add the coefficient, in case of multiplication we simply add the power. So let's do these also. So 4 into 3 is 12. A to the power 1, a to the power 1. 1 plus 1, 2, a to the power 2. In this one, 5 into 2 is 10, x to the power 1, x to the power 1. So x to the power 2 minus 7 into 5, 35. X is only 1, there is no x here, so 35x. In this case, x into x plus 4 into x plus 6 into x plus 4 into 6. Simple x into x is again addition of power. So x is x to the power 2 plus 4x plus 6x plus 4 into 6 is 24. which is nothing but x square. These are like terms. We'll add their coefficient 10x plus 24, right? With that, let's move to the last one. Again, the same thing, nothing new. 2m into m plus 3 into m. So these two. Now minus 5 into 2m minus 2m into 5 minus 3 into 5 plus into minus. This plus into minus is always minus, right? So that's the reason when we multiply anything by minus 5, it will become minus. So here 2 into m to the power 1 and 1, 2 plus 3m to the power 1 minus 2 into 5, 10, m to the power will remain 1 minus 15. Now these are like terms. So 3 minus 10 is minus 7. So 2m square minus 7m minus 15. So that's how this problem is solved. Now comes degree of a polynomial. Degree of a polynomial is a very simple concept. Please don't get bogged down by that hi-fi terms as such. Degree of a polynomial is whatever is the variable that's there in the polynomial, right? So in a polynomial, there are multiple terms. There is one term, there is second term, there is third term, right? So for each term, we will find out the highest power of the variable, power of all the variable. So like if we look at this one, 2x to the power 4 minus 5x square plus 3, right? So here the highest power of x is 4. So for this one, the highest power is 4. For this one, the highest power of variable is 2. For this one, there is no variable, so highest power of variable is 0. So now out of these three, whichever is the highest, so 4 is the highest, so the degree of this polynomial will be 4, right? Now, let's look at this one. Highest power of the first expression, 7y square, is 2. The highest power of second expression is 1. The highest power of third, sorry, not expression, term. Highest power of third term is 0 because there is no variable. So highest of these three is 2. Now let's look at this one. This is the first one. When we talk about highest power of variable, we have to add the power of all variable. So 3x square, y square. In this case, x to the power 2, y to the power 2. There are two variables. We'll add these two power. So 2 plus 2 is 4. So in this particular case, 3x square, y square, the degree of this term is 4. x3, y, again the same thing, x to the power 3, y to the power 1. Y means y to the power 1. So 3 plus 1 is equal to 4. So in this case, both the term has a degree 4. This is 4. This is 4. So combined, this polynomial will have a power, or rather a degree of 4, right? Now, if there is a constant, we already discussed. So 3, there is no variable. So the degree will be 0. And 0 polynomial means only 0. There is no degree defined because 0 to the power nothing. We can't put a term which will be equal to 0. So this we just need to remember. There is no degree to 0. Now let's come to the practical example. Here the highest power is 3. Here the highest power is 1, here the highest power is 0, so the power of this polynomial is 3. In this case, the first term 2 plus 3, highest power is 5. Second term a to the power 1, b to the power 1. So in this case, the highest power is 2. So first term highest power is 5, second term highest power is 2. As a result, the degree of this polynomial is 5. Now in this case, the first term highest power is 1, x to the power 1, so 1. In this one, the highest power is 0 because constant do not have a variable, so power of variable is 0. So the degree of polynomial is 1. In this case, there is only one term, and the highest power of that term is a to the power 3 plus b to the power 2, so 3 plus 2 plus c to the power 1, right? So 1. So the total power of this term is 6, and that would be equal to degree of the polynomial, because that is what, there is only one term in this polynomial. And then comes the last one, 0, which do not have a degree. Now, whenever we get an algebraic expression, we have to simplify that algebraic expression. And that's where we are entering into some interesting domain now. So in an algebraic expression, there might be brackets used. So how many types of brackets are there? There is a small bracket, there is a medium bracket, there is a large bracket. I have just given them the name that way. So a small bracket, then medium bracket, then large bracket. Now, if any expression has brackets, in that case, we have to solve the smallest bracket first, then the medium bracket, then the large bracket, right? So, say for example, this one, there is only small bracket, so we have to solve it first. 3 plus 5 is 8 into 2, and then only we will multiply, answer is 60. In this case, there is first a small bracket, then a medium bracket. So first we'll solve the small bracket. 3 into 4 is 12, plus 2, which is 14, and then minus 5 is 9. Right? Now let's come to this example. There is a small bracket, there is a medium bracket, there is a large bracket. So first we'll solve the small bracket, 2 into 4. So that will come as 8. 8 plus 3, then we come to medium bracket. 8 plus 3 is 11. So medium bracket also solved. Then we come to the last bracket, which is large bracket. So 5 plus 11 is 16. So always remember, we have to solve the innermost bracket first, the small bracket, then medium bracket, then the large bracket. Now, once you remember brackets, you need to remember badmas or BODMAS, as we say. Okay. So BODMAS, what does it say is, in an algebraic expression, whenever we have an algebraic expression, the first thing we have to attack is the brackets. B for bracket. And in bracket, we already saw we have to attack the smaller one first, then the medium one, then the large one. So that's the first thing we will be attacking. Then the second thing we need to solve is orders. So if there is any power, root, squares, etc., we have to solve that. And we'll come to different types of algebraic expression. We'll see it there. After we have solved the orders, we have to solve the division. So after the order, the next thing we need to solve is division. After division, M for multiplication. After multiplication, A for addition. And after addition, S for subtraction. So subtraction is right at the end. Right? So BODMAS, just remember BODMAS, and in BODMAS, remember the meaning of each one of them. B for brackets, O for orders, D for division, M for multiplication, A for addition, and S for subtraction. That's the BODMAS rule. Now let's look at this. So first what? First is as per multiple. There are two things here. One is addition, one is multiplication. As for BODMAS, M come before A. So we have to solve the multiplication first, which is 2 into 3, 6. And then we have to solve this addition. So 6 plus 6 is 12. Now there is a bracket, there is a multiplication, and there is a addition. Which one has to be solved first? First the bracket. So inside the bracket, whatever is there, we have to solve that first. 5 plus 3, 8. Then we have to solve multiplication into 2 equal to 16. Now here we have 20, then we have a division, we have a multiplication. So we already saw in BODMAS, BOD, D is division. So division has to be done first and then we have to do multiplication. So 20 divided by 5, which is 4, into 2, which is 8. So BODM. So first division, then multiplication. Now let's come to this is what all is there. There is a subtraction, there is a addition, and there is a power, 2 to the power 4. Now in BODMAS, what was there? BOD. So there is no bracket. O for order, which is power. So we have to solve order first. So 2 to the power 2 is 4. So we solve that first. Then out of this, what is the next thing that we need to solve? If there is a addition and subtraction, it has to be from left to right, or even addition you can do first. So plus 6 minus 4 would be 2. 10 plus 2 would be 12. So answer would be same, or go from left to right as mentioned earlier. So 10 minus 4 is 6, and then plus 6 equal to 12. Addition subtraction is no big deal. Now let's practice few of this. So in this one, B O, there is no B, there is no O order, there is no D division, there is a multiplication. So M. So we will again write it down, BODMAS, right? So first thing in BODMAS, B, O, D are not there in this expression. M is there, so we have to solve it as M first. 3 into 2, 6. So 15 minus 6. Now there is no A, there is a S, subtraction. 15 minus 6 is equal to 9. Now let's come to this bracket. Yes, there is a bracket, 12 minus 4, so we'll solve that. 8 divided by 2. After bracket, there is no O order, there is a D division. So we will solve that. 8 divided by 2 is 4. Now let's come to this. Is there a bracket B? No. Is there a order O? No. Then is there a division D? Yes, there is division. 6 divided by 4, 2. So we'll solve that first. So we'll solve this part first. 6 divided by 2. So that becomes 3 into 5. Now again D we have already solved. The next is M. So 3 into 5 is 15. So 3 plus 3 into 5, 15. Now A addition, 3 plus 15 is 18. Now let's come to this one. Now, is there a bracket B? Yes, there is a bracket B. So whatever is inside that bracket, we'll solve that first. So this becomes 10. 10 to the power 2 minus 10. Now, is there a order? Yes, 10 to the power 2 is the order power. So we will solve that first. 100. 100 minus 10. So from there, is there a division D? No. Is there a multiplication M? No. Is there a addition A? No. Is there a subtraction S? Yes. So 100 minus 10 is 90. Now let's come to this one. Is there a bracket B? Yes. So we'll solve that first. 100 divided by whatever is there inside the bracket, 5 into 2, that is 10, plus 4. Now after bracket, is there a order O? No. Is there a division D? Yes, there is a division. So we'll solve that next. 100 divided by 10 is 10. plus 4. Now, D is done. Is there a multiplication? No. Is there addition? A. Yes. So 10 plus 4 is 40. That's how we are going to simplify the algebraic expression. Now this I am leaving for the time being. You can do it. It's in the similar way that we have discussed in the last. Yeah, all we need to do is solve the bracket one after another. Small, then medium, then the large one. Let's do one of that. Okay, so let's do this one. So what we have to do, we have to solve the smaller one first. So 6 plus 3, 9. So the way we are going to write is 50 minus 18 minus 9. Now, what we have to do? We have to move from inside to outside. So from here, although large bracket is there inside, 50 minus 18 minus 9 is 9. And then 50 minus 9 is 41. So that's how we are going to solve this entire algebraic expression. So that's more or less all about algebraic expression. I don't really, I'm not looking for your like, subscribe, or comments as such. If you do that, that's really nice. But I put a lot of effort and would really appreciate two things. One, uh, on what topic can I make my next video? If you let me know that, that would be really great, either through comment or through email. And how can I improve my teaching